Okay. So from geometry, do we remember what a rigid transformation is?
No.
No. Okay. Well, thinking of another way I could put it. Trying to think of the word. I forget. Whatever. A rigid transformation doesn't change the shape of what we're dealing with. Okay, so in terms of geometry, it would be a translation, a rotation, or a reflection. All right. Now, essentially, we're going to be doing most of those except really rotation. Excuse me. It's kind of hard to rotate a graph. All right, but it's real easy to reflect it and to. Oh, excuse me. Pull up. Pardon. Translations and reflections. Okay, so the first, I'm going to give you the kind of algebraic definition, all right, and then we'll take a look at some graphs and how that works. So first we have vertical and horizontal shifts, also known as just translations. Okay, so we're moving the graph up, down, left, right. Okay, so we're going to have some number c. It's going to be a positive real number. Okay, and then we have our function f of x, right? So I'm not defining what the function is. I'm saying this applies to all functions. Okay, so first, if I want to vertical shift my function up, okay, my new equation, right, is going to be h of x. I'm going to take f of x, and on the outside of the function, I'm going to add that number. Okay, so plus c on the outside. Right? If I want, to go down, all right, my new function will be the old function minus c. Okay, if I want to have a horizontal shift, my new function, I'm going to manipulate now inside the parentheses, and I'm going to have x minus c. Okay, be careful here. Vertical shift goes along with common sense, right? If you want to move up, you add. If you want to move down, you subtract. Our horizontal shift, notice if I want to move right, I'm going to subtract. Okay, so that one is kind of backwards. And then we have horizontal. If I want to shift left, on the inside again, I'm going to now add C. All right, so yeah, it's a lot of letters right now, so let's actually take a look at what this means. So let me get this.
Can I copy that down real quick?
Yeah. Sorry.
Right.
So we're going to deal with a very basic function, x squared. Let me know when you're good, and we'll move on. That's an H. They're all H's there. That one's a little sloppy.
That's E. You can go, I think.
Okay.
Wait. Let me take a picture real quick.
Okay.
All right, you're good.
All right. So here we have our basic function x squared. Okay. Normal parabola. The vertex is at 0, 0. Right. Nothing special about it. So, okay, again, if I want to do a vertical shift, what I'm going to do is I'm going to add, if I want to go up 2 units, I'm going to add to the outside. Okay, so now see, these two graphs are exactly the same. That's a little too far out. Right, but this black one here, my second one, is up 2 units. Okay, I take every point and I move it up 2 units. Okay, so I added on the outside. If I subtract, if I change that to -2, right, it moves it down 2 units. Right? So again, notice my basic function was x squared, and I'm adding and subtracting on the outside of that. Right? So that's outside of the parentheses. Okay, and that gives us our vertical shifts. Okay, now in order to do it horizontally, what we have to do is we have to manipulate our x value. So I'm going to remove the outside part. And now, if you notice, like in here, okay, it's going to be inside the parentheses. So we have to add parentheses. I'm going to get rid of this squared for now. So if I want to move it to the right 2 units, I'm going to subtract 2. And then I'm going to put the squared on the outside. Okay, so here, notice, I have x -2 in parentheses squared. So that squared is telling me, okay, I'm going to have my basic parabola, right? And this -2 on the inside of the parentheses tells me I take all of my points and I move them to the right 2 units. Okay, and then again, if I add 2 instead of subtract 2, that moves us to the left for 2 units. Right? Now this can be applied to any of our functions. Right? So if I had the square root of x, okay, there's my parent function. If I had the square root of x, and then on the outside I put +3, well, I take this and I move it up 3 units. I can do 2 translations at once. Okay, so I can move up and down and left and right. So underneath, I put -1. Okay, so notice now, this is telling me that I'm moving up 3 units and right 1 unit, right? And again, if I look at, this point here, 0, 0, I can take this point 0, 0, I can move it right 1 and up 3, and that's where my new start of the graph is, right? And they look exactly the same. If I go on here, these are kind of, even though they're not straight lines, they're pretty much parallel. They will never meet. Okay, so there's 2 ways you can do it. You can do it in the actual equation like this, okay, or you can show it in function notation like we have over here. All right, so that is our vertical and horizontal shift. The other type of non-rigid transformation that we have is easy, or easier, I should say. Okay, is reflections. For now, we're only going to deal with 2 reflections. Okay, we can reflect over the x-axis, right? So that would be going from the top to the bottom, or the bottom to the top. Oops. I'm excited here. I hit my own camera. Okay, also known as a vertical reflection, right? Because we're going over the x-axis. To do that, our function, I would just throw a negative in the front of the function. Okay, and we actually, right? You said that the other day. If you have x squared is a normal parabola, well, negative x squared would be an upside down parabola. I will mention too, this is our most common reflection, all right, when we throw the negative in front to flip it over. We can also reflect over the y-axis, okay? And to do that, you're not going to change the outside, you're going to change the inside. So you're going to have f of negative x. All right, so I'll give you a second to finish that, and then again, I'll show you. Let me just move this with the graph. Now, sometimes one of the reflections might give you the same exact picture. Okay, and I'll show you with our very basic example, x squared. Okay, so again, here's our x squared. So if I throw a negative in front of it, right, we see that reflection, right? Here's our x-axis. It flips over from the top to the bottom. Try to get it so you guys can see. Okay, so you have the x squared is your upper one, and your negative x squared is down here. Now, if I put this in parentheses, they're going to be the same thing. Okay, and that's because we have a special condition that x squared is an even function. So it's already symmetrical over the y-axis. So, you take this side and you move it over here. Well, that's going to lay right on top of the other side, right? So they're going to be the same. So sometimes reflections don't really work. All right, so let's take a look at x to the third. Okay, so now if I want to reflect it over the x-axis, okay, this top line is going to go down to the bottom. So I'm going to have the negative x to the third there. Okay, now notice too, now, if I do a separate one, well, that actually gives me the same one. Here, my x-axis reflection and my y-axis reflection end up being the same thing. Okay, these two are the same. So this really, let's do the square root. Oops. Nope. Come on. All right, so let's take a look at the square root of x because this one's nice, right? It's only in one quadrant. So over here, that's our square root of x. Reflection in the x-axis, negative square root. All right, that's going to put us in the bottom. And notice this is a sideways parabola. We'll come back to this next week. Okay, but here I can now flip this over, and if I put a negative x in there, right, that flips it over the y-axis to the other side. All right, so this purple one is our x-axis reflection, and this one is our y-axis reflection. All right, so this one you can see a little more clearly. Okay, any questions so far? All right, so last part. Okay, we're going to talk about is, oops, that's out of view, non-rigid. Okay, so this in geometry would be like a dilation. Okay, right? You're making something bigger and smaller. Now, you're not necessarily changing the shape, right? You're just changing the size of it. That's in geometry, okay? Here, though, we're actually sort of changing the shape, okay? We're still going to have the same general look and feel of it. Did they give me rules? No, they don't. Okay, so we do non-rigid transformations. Okay, we have two types. Now, they might be called different things, but this is what we're going to stick with. Okay, we're going to say we have a vertical stretch. So all we're really doing here is we're multiplying our function by some constant. Okay, C is just some number. So we get a vertical stretch if C is greater than 1. Okay, so if we look at x squared again, because that's a very basic, easy function, right? This would be my normal x squared. So if I did a vertical stretch and say I did 2x squared, we'll do it in red here, right? It stretches it up vertically, right? So another way you can think of it is it makes it narrower, right? But think of it, we stretch up, right? So if your arms are apart and you're stretching up, right? Your arms are apart and you stretch up when it's a larger number than 1. Okay, so 2, 5, whatever like that. If you had a negative, right, it would just stretch it, but it would flip it down to the denominator. Then our second type is a vertical shrink. Okay, and this is when our constant is a fraction or a decimal less than 1. Okay, so C is going to be in between 0 and 1. I don't want to just say C is less than 1, because once I get into the negative numbers, we go back to the vertical stretch. Okay, so an example, if I had 1/2 x squared, okay, so that's going to shrink us vertically. So it kind of flattens us out, and we're going to have a wider parabola that way. Okay, any questions on that? All right, so this is the basics. I'm going to give you guys some work, and all you have to do is identify what's happening. Okay, so just to show you, I know we only got 2 minutes, but as an example, right, I'll give you something that says f of x plus 2 minus 1. So you're going to have to tell me that the graph moves 2 units to the left because of the plus 2 and 1 unit up, right? But it'll be multiple choice, so you'll have the options to pick from. Okay, so just be careful. Remember all of your rules. All right, like if there's a 2 up there, you would say and vertical stretch. Okay, so right now I'm just we're going to be more focused on identifying what's happening rather than actually graphing it out. Okay, and then maybe what's today, Wednesday? Yeah, maybe tomorrow I'll just give you guys some practice with the actual graphs and how they look like. Okay, any questions, concerns, or comments? All right, guys, then that's it for us today. Enjoy the rest of your day, and I will see you tomorrow.
Bye.
Bye-bye.
Bye.
Bye.